Hello and welcome everybody. Thank you for visiting my channel, Just a Guy Who Likes Math. Today I'm going to show you how to find the last digit of a power. Now let's say the number is x, y, z to the nth power. Now x, y, z aren't individual numbers themselves. Z is actually the units place, y is the tens place, x is the hundreds place. Now, to find the last digit of x, y, z to the nth power, you need to find the last digit of z to the nth power. I'm going to give a reason for all of this right after I explain all these 4 steps. But let's just move on to step 2 for now. You need to find the cyclicity number of z. Let's call that c. And I'm going to explain what cyclicity is too. Step number 3 is find the remainder of n divided by c. N is this exponent over here. C is the cyclicity number of z. And step number 4 is kind of split into 2 cases. When the remainder greater than 0, when the remainder is greater than 0, find z to the r and find the last digit of that. And when the remainder equals 0, find z to the power of c. Now c is the cyclicity, and find the last digit of that. Now r can never be negative because it's remainder. So yeah, we only have 2 different cases. Now let me explain the steps. First, we need to find z to the n. Now why is that so? Now I'll just give a quick example to kind of highlight the case. Let's say we have 12 to the power of 2. We all know that's 144. Now 12 times 12 could also be represented as 12 times 10 plus 2. Now that's equals 120 plus 24, so equals 144. But the last digit of this is only affected by this 2, which is the last digit of the number 12. And that's the reason. These high the hundreds places and this tens places and so on and so forth, all these numbers, they won't really affect the last digit. So the last digit only affects by the units place number over here. I hope that made sense. Step number 2, find the cyclicity number. Now what the hell is the cyclicity number? Cyclicity is, let's say you have a number a, and you do a to the first power equals a to the second power could be some other number b. A to the third power, it could be some number with the last digit as b. Now a to the third power could be some number with the last digit of c. And a to the fourth power could be some number with the last digit of d. Now a to the fifth power could be some number, but if it's a certain few numbers, the last digit will be a again. So the cyclicity are these 4, it has 4 unique numbers, right, over here. So cyclicity is 4, cyclicity of A. So we found that. So the cyclicity number, now step 3. Now we just divide n over c, and we just get the remainder. And the next step, I think that's step number 3, is quite simple. And step number 4 is, it's like I said, it's split in 2 different cases. If r greater than 0, find z to the r power, z to the power of r, and find the last digit of that. And when r equals 0, find z to the c, and find the last digit of that. Hope all that made sense. I think I'm going to explain with an example. It usually helps me out. So let's see what example we have. I'm going to use like a very large number. So I can't use a calculator. So let's say example is 127 to the power of 39. Now this is going to be really hard without a calculator. You can't really find the last number. So let's just take it step by step. Step number 1. So to get the last digit of this number, you will actually need the last digit of 7 to the 39. Now, step number 2, find the cyclicity of 7. So 7 to the first power equals 7. 7 to the second power equals 49. 7 to the third power equals 343. 7 to the fourth power equals some number, but the 3 times 7, 21. So the last digit is going to be 1. Now 7 to the fifth power equals 1 times 7, some number with the last digit of 7. So the cyclicity equals 4. Now step number 3, n divided by c, and you have to find the remainder of that. So it's 39 divided by 4. 4 times 9 equals 36, so the remainder equals 3. Now step number 4, since the remainder is greater than 0, what we do is that we do z to the power of r. So 7, the last digit of 7 to the 39 will also be the last digit of 7 to the power of 3. Now we got this number, 343, so the last digit is 3. So the last digit of 7 to the 3 is 3. Now the last digit of 7 to the 39 will also be 3. But from step 1, we know that the last digit of 7 to 39 is also equal to the last digit of 127 to 39. Hence, we know the result. The last digit of 127 to the power of 39, whatever the large number is, will equal 3. Now, I do have a couple of tips and tricks for you. They will help in step number 2. Some of them, I have 4 tips for you. Tip number 3 and 4 will help in step number 2 and 3. Tip number 1 and 2 will only help in step number 2. But let's see what they are. So, any number, any integer ending with 0, 1, 5, or 6 will have the last digit of anything to the power of whatever will always be the same number itself. That kind of makes sense, right? Let's say 16 to the 6th power, 16 to the first power 6, 16 to the second power, it's always gonna be 6. Same with 5. 125 to the 15th power, it's gonna be, the last digit is always gonna be 5 times 5 times 5 times 5. So it's always gonna be something 5. Same with 0, same with 1. Now, tip number 2 is that integers that end with 2, 3, 7, and 8 will always have the cyclicity of 4. And let me explain it. I'll just take 8 as an example. You guys can do 2 and 3. But 8 to the first power equals 8. 8 to the second power, 64. 8 to the third power, I don't know off the top of my head, but 8 times 4 is 32, so something 2. 8 to the fourth power equals 16, so some number 6, the last digit. 8 to the fifth power equals 6 times 8 is 48, so some number, and last digit 8. So again, cyclicity equals 4, the 4 unique numbers, because this number is the same as the first one, so cyclicity equals 4. Now, tip number 3. Now, integers ending with 4, that is, x, y, 4 to the nth power, this is 4, will always have cyclicity equals 2. However, it's a little easier because when n is odd, so if n is odd, you get the number will always end with 4, and if n is even, the number will always end with 6. And I'm running low space, I have to use a new page. And last tip for you guys is right over here. If the integer ends with 9, so like we did 4 before, but x, y, 9 to the nth power, it will also have a cyclicity of 2. And when n is odd, so if n is odd, it will end with 9. The last digit will always be 9. And if n is even, it will always end with 1. Let's say example is just the number 9. 9 to the first power is 9. 9 to the second power is 81. But this 1 times something, 1 times the 9 will always equal 9. So if n is odd, it'll always end with 9. If n is even, the digit will always end in 1. Alright guys, I hope this helped. If you do have any questions, feel free to type in the comments below. But until next time, peace out.